going to start 6C today, and it's brand new, something you've never ever seen before. So it's going to be real important that we're all in and kind of focused today, okay? We're going to be looking at something called trigonometry, and trigonometry as a branch of mathematics is very, very large, and there's lots of things. There's like functions, trig, there's a whole class here, algebra 2 trig is a whole class here. We're going to do a little tiny subset of trig, and it's called right triangle trigonometry. So anything that we deal with has to be in terms of a right triangle, okay? But there's all different kinds of other parts to that branch of mathematics, and hopefully someday you'll get to that. It'll be a good exploration for you. But what we're going to focus on today are these three functions. There are 6 total trigonometric functions, but for us, we're only going to deal with 3 of them. And they are on your calculator, and we're going to use our calculator in a few minutes, but they have abbreviations, okay? The abbreviation for sine is SIN. Go ahead and take a look at your calculator and see if you can find that abbreviation on your calculator, SIN. Make sure you see where it is, right? Cosine, and please don't say sin. I realize that that's what you want to say, but it is the sine, okay? It's a little pet peeve of mine. Then we have cosine, and its abbreviation is COS, okay? So that, again, just means cosine. And then the abbreviation for tangent, what do you think it's going to be? 3 letters, 3 letters. Look at your calculator. Yeah, TAN, tangent, okay? So we have sine, cosine, and tangent, and we're going to look at what those are. They're actually what are called trigonometric ratios. Remember what a ratio is. We'll look at that in a minute. But on your calculator, you should be able to find those. Interesting. You want this guy? Find those right here in the middle, right above kind of like in the middle, right above the white key, sine, cosine, and tangent. And you'll notice above them they have a sine with a little -1, a cosine with a -1, and a tangent with a -1. And we'll do that on Friday, okay? But right now we're just going to look at these 3 trigonometric functions in and of themselves. One thing that's really, really important, and I want to make sure you really hear this, when your calculator is reset, like we reset the memory on your calculator, the default is the wrong one. So no matter what, when you come into class, you need to check the mode. So can everyone hit the mode key for me right up here at the top? Hit the mode key. Put your phone totally away. I realize you probably have something going on, but I don't need to see it out. When we go to this right here, the 3rd line down, you see the word radian highlighted. Radian is a different way to measure angles. Just like degrees, you can do Fahrenheit or Celsius, right? 2 different scales. There are 2 different ways to measure angles. One is in degrees, and one is in radians. We don't know anything about radians at our level right now, so we're not going to do that. Unfortunately, that's the default, okay? So you need to change manually your calculator to degrees. So I just want you to be in the habit of any time you're going to be using the calculator for trig, that you're going to check the mode and make sure you're in degree mode. If you're using a calculator, like a different kind, not a graphing calculator, there is a DEG button or an RAD. It just hit the mode. You want DEG for degrees to be on. Does that make sense? Always in degree mode. Perfect. So that's the first thing. So go ahead and make sure you're in degree mode, and then put your calculator kind of aside for me for just a second. All right. So you don't have to write this part down. I'll tell you what's important to write down in your notes. But I do want to define the word ratio. Okay? So when you read that, the ratio is basically a comparison, right? It's a fraction. Do you agree? We're going to write these trigonometric things, ratios, as fraction. Another word, fraction. Sometimes you can write them as a decimal. And I've seen them written both ways. Okay? So we're just going to be able to figure out what they mean. We're going to start as a fraction, and sometimes they'll go in as a decimal. So let's look in terms of this particular right triangle. Again, don't write this one down. I'm hoping that we can see. Oh. Can you see this right triangle is 5, 12, 13? Is that okay on the right-hand side? Okay. So looking here, it says circle the ratio, which means the fraction, of the length of the longer leg to the shorter leg. So longer leg over shorter leg. Looking at that picture, what would that be? Longer leg over shorter leg would be 13 is on a leg. 13 is the hypotenuse. So it'd be 12 over 5. Good. We're talking about legs. Remember that this guy is a leg, this guy is a leg, and this guy is the hypotenuse. Do you agree? Okay, so longer leg over shorter leg is going to be 12 over 5. What about the shorter leg to the length of the hypotenuse? That's going to be 5/13. Okay, very good. And then how about longer leg to the hypotenuse? 12/13. Okay, perfect. So we know how to figure out, looking at the triangle, what numbers we're pulling together. That's not the hard part. Trig, and this is what you're going to write down, okay? So go ahead and draw this picture, this triangle, is a relationship between angles and sides. The Pythagorean theorem that we did up to before now with 6a and b was only side measures. I knew nothing about the angles except for we had right triangles. Trig deals with both angles and sides. You have a mixture, okay? So the sine of A, I like to write it like this. So maybe we should, rather than label it A, B, and C, we should label this as opposite, hypotenuse, and adjacent. Okay? So label them this way, if you would, please. The sine of an angle. So you take a trigonometric function, sine, cosine, and tangent of an angle is equal to this particular fraction. The sine is the opposite over the hypotenuse. Okay? So make sure you have OH and A, and then you're going to write what the sine is. Sine is opposite over hypotenuse. Look at what I've written here. The cosine is going to be the adjacent over the hypotenuse. And the tangent is going to be the opposite over the adjacent. Okay? You might hear something called SOHCAHTOA. SOHCAHTOA. Can't sing. I like to yell like I'm an Indian. SOHCAHTOA. SOHCAHTOA. What does that mean? So, S-O-H, sine is opposite over the hypotenuse. Cosine is adjacent over the hypotenuse. And TOA, tangent, is opposite over the adjacent. Just like a way to remember it, okay? SOHCAHTOA. Remember that it's all in relation to angle A, okay? What if I changed this and I changed it to be angle B? So here's angle B. We have to relabel the sides in terms of the opposite, the adjacent, and the hypotenuse. When you look at angle A, isn't this side the opposite side of the angle? That's why I labeled it with an O. Isn't this side the adjacent side? Adjacent to angle A? That's why it is labeled the A. And then the hypotenuse doesn't change. Do you agree with that? The hypotenuse is always the longest side. In relation to angle B, which side is the hypotenuse? Use letters. I have to tell you which angle is the right angle, don't I? If that's the right angle, AB is the hypotenuse, so we're going to label it with an H. Which side would be the opposite? AC, very good, because it's across from angle B. And then which side would be the adjacent? BC, good. So first thing you always want to do is on your picture, figure out what angle we're talking about. So if we're talking about angle B, this is how you would label it. If we're talking about angle A, you have a different picture. The hypotenuse stays the same, it's just that the opposite and the adjacent will switch. First step, label your sides, OH and A. We good so far? Okay. So let's try one, okay? Let me see if I can get this to... There we go. So draw this as example 1, problem 1, example 1. You want to draw this into your notes. So you have SOHCAHTOA written down. Let's go ahead and do example 1 here. Okay? This time you have numbers associated with it. Okay so far? Can I check to make sure it's a right triangle, by the way? How would I check? What do I do? Do you remember? If it's a right triangle, doesn't a squared plus b squared have to equal c squared? Let's check it. Go ahead and check it. What's c? What number? 17. Good. So we're going to say 17 squared. And that should equal 15 squared plus 8 squared. Is it a right triangle? Yes. Good. I've got a right triangle. I'm good to go. So I want to be able to write the trigonometric ratios in terms of angle G. So let's go ahead and label angle G. And then let's do our OH and A. With respect to angle G, which side is the opposite? Which is number 15, right? Yeah. So yeah, but you're right. Segment TR. So we have our opposite. Which side is the adjacent side? 8 or GR. And which side is the hypotenuse? GT or 17. So based on that, I want us to write the sine, cosine, and tangent of my angles. Okay? So what is the sine of G? This is how you write it. The sine of G equals, the cosine of G equals, and the tangent of G is going to equal. And we're going to literally write the fractions. That's it. So what is the fraction for sine? SOHCAHTOA. So sine is so, opposite over hypotenuse. 15 over 17. Very good. Any questions as to where those numbers came from? SOHCAHTOA. Derek. So remember, so S equals O over H, right? Sine is opposite over hypotenuse. So the opposite one is 15, and the hypotenuse is 17. Okay? Let's try cosine. So ca, so that's adjacent over hypotenuse. So what numbers are going to go where? 8 over 17. Very good. So CAHTOA. TOA is opposite over adjacent. So what's that one going to be? Yeah, 15 over 8. Very good. So we have to be able to write the ratios, and then we're going to use the trig functions to solve for things. Today, we're only solving for missing sides. Do I have any missing sides yet? Not yet. So we're going to look at one where we do. But we have to make sure we can find the ratio. Are we okay so far? Sometimes it'll be an x. Put the x where it belongs. That's okay. Okay? So let's look at this particular problem. This is one we're going to actually do. So look at this picture. This will be example 2. And we have to be able to solve for W. So we have 54 degrees. This time we're given an angle measure, aren't we? Come on, Rodney, let's write this down. Example 2, Sweet Pea. Okay? This time we have an angle measure. And we're trying to solve for a missing side. And that's what we're going to focus on today, is solving for missing sides. On Friday, we'll look at solving for missing angles. I have a combination of angles and sides, so I know I'm going to use trig. If it was only sides, what would I be using? What did we use before? Begins with a P. Pythagorean theorem. Only sides is Pythagorean theorem. A combination of sides and angles is trig. So we have an angle. Let's label our O, our H, and our A. We only need to label the ones we need. What is 17? An O, an H, or an A? That's an H. Good. And then how about the W? Is that an O, an H, or an A? With respect to 54? O. Very good. We don't need to label the other sides because we don't have any information about it. But the top would be the A, but we don't need to label it. That's just extra to confuse you some more. Derek. It is. We're solving for the variable W. So you want to label the sides with OH or A that are given to you. Which trig function, sine, cosine, or tangent, relates O and H? The sine. So katoa, right? So that tells me that the sine of my angle is equal to the opposite over the hypotenuse. This time we have a degree measure. What is it? 54. So the sine of 54 is equal to, and then what am I going to put my fraction over here? W is the so opposite over hypotenuse. So W over, perfect, W over 17. Before we go any further, I really want to make sure you understand where that equation came from. We okay with why it's sine? We okay with where the fraction came from? Why the degree measure's in there? All good. Okay. Now, I want you to type into your calculator for me. Remember, we already put it in degree mode, right? The sine of 54. Go ahead and type that into your calculator. The sine of 54. Do it for me. Tell me what you get. You get a number, don't you? Did you get a number? The sine, cosine, and tangent are just functions. If you put a number in there, you put an input, you're going to get an output. The input is 54. It's like domain and range, if you remember that from algebra. You have an input, you have an output. The input is 54 degrees, you're going to get an output. Are we okay with that? All right? So the sine of 54 is just like a number. It's like f of 2 if you think about algebra. It's just a number. Yes?
How do you get the 54 next to the sine?
Because that's the formula. Because if you look back here, what we did, it's the sine of the angle. We just happen to know what the angle measure is. Okay? So rather than write the letter G, we put in the degree measure. Okay? It's always the sine, cosine, or tangent of the angle is equal to. So here we just happen to have what the angle is. So we put it in. Okay? So you guys told me it's 0.8, or I don't forget what you said. 0.809, thank you. So we have 0.809 is equal to W over 17. What would I do here? How do I solve for W? Let's remember back to algebra. Good, I'm going to multiply both sides by 17, because it's like right now it says W divided by 17. So if I multiply both sides by 17, these cancel, don't they? So W is just equal to 17 times whatever you just did. So what's W? Once you're in degree mode, you can type in, come on, turn my calculator on. There we go. We can do the sine of 54. Oops, not the tangent. There we go. Sine of 54. Don't forget to close your parentheses. And then we'll multiply it times 17. Did you see what I did? Okay. And then just hit enter. 13.75. Sound good to you? 13.75 is the length of W. We're solving for lengths. We're solving for the length of the side. Okay? So W is 13.75. Some people like to do it all in one step. So I'm going to show you that just so you can see what I'm talking about. If I have the sine, let me do a different color. If I have the sine of 54 is equal to W over 17. Can I just multiply by 17 right now? If I multiply by 17, don't I have just W? So W is equal to 17 times the sine of 54. You can, on your calculator, type it all in at one time. 17 sine 54. It assumes that's multiplied, by the way, and you'll get the same answer. Okay? So you don't have to do it in two steps. It's totally up to you. What's really important is what mode do we need to be in? Degree mode. All right. I'd like to try one more before I give you guys some problems to try. Fair enough? Okay. So let's try one more. Whoa, let me draw it. So let's say I have this example. I don't know. I'm making numbers up. Okay? So let's go ahead. Remember the steps. Step 1 is going to be to label my O, H, and A. Do you agree? I don't want you to label all 3 sides. I only want you to label the ones that are given to you. So Lexi, I want you to look at 10, and I want you to look at 5. Okay? We want to figure out, actually, let's do it this way. Let's redo this. Can we redo this? Let's solve for this side as x. Okay? So don't worry about the 10. Let's solve it for this. So we only want to label an x and the 5 right now as O, H, or A. Since the hypotenuse is not labeled with anything, I'm not going to deal with the hypotenuse. Okay? Don't care about it right now. So let's label O, H, and A. That's step 1. So let's do it. What's the 5? O, H, or A? It's not O. It's the A. It's the adjacent side, isn't it? So this is my adjacent side. What's the X? That's my O, because it's across from angle 27, isn't it? So this guy right here is my O. So I have the O and the A I'm dealing with. What trig function is that? Sine, cosine, or tangent? That's tangent. So, ka, toa. Toa is tangent. So I'm going to say the tangent of, what's going to go inside those parentheses? The tangent of what? The angle measure. Good, 27. Is equal to, now I have to write my ratio or my fraction. So what's the ratio? X over 5. Very good. What do I do now? Multiply both sides by 5. And just type it into your calculator. Tell me the length of x. What is it? 2.3? 2.3? 2.26? That's fine. How do we feel so far? Label O, H, and A. The second step is going to be to decide if it's sine, cosine, or tangent. And then we're going to have to solve. That's it. It's that basic. The only thing that will get difficult is if my x is not there. So let me do one more thing with you, and then I'm going to have you guys practice, okay? The only thing that may get difficult is if the x is not in the top. Let me show you what I mean. If I have the cosine of 25 degrees is equal to 3 over x, let's just say that I